Hi guys, welcome to our chemistry class today. And we have talked about electrolysis of different substances using different anode and cathode before today. And now we are still going to talk about electrolysis of concentrated sodium chloride, or you call it electrolysis of brine using mercury electrode. We have changed our electrode to mercury now. Let's see what will be the effect of that. Now, we remember I told you at the beginning of these classes, that we have three conditions that affect the discharge of ions. And the first one we talked about was the position of ions in electrochemical series. The second one, the concentration of ions in the electrolyte. And the third one was the nature of electrode. We have done justice to these other two. Now we want to see the one that has to do with the nature of electrode. Now the nature of electrode here, in the previous electrolysis we did, we were using inert electrode, and we saw different things that were produced at the anode and at the cathode. Now we are going to see, now that we are using mercury, what will happen. At the anode, you will see what will happen, and then the electrolyte is still sodium chloride and water dissolved together. You have sodium ion, you have hydrogen ion as the positive ions from them, and you have chloride ion and hydroxide ion as the anions from each of them. Now, in this electrolysis, when you connect electric current into it at the anode, you need to know that anode here is plus, which is platinum. Now at the anode plus, the two minuses will move down there to contest on which one will be discharged. So two of them will go, and they are close by on that electrochemical series. So we will not consider the position, we will rather consider the concentration. Chloride ion is of higher concentration. Remember we said concentrated. Okay, now so at the anode, Cl minus will give out its electrons at the anode, that the electron will flow down to the cathode, whereby itself will turn Cl plus E minus. That's what happens. And since other ones are also going through the same process, so chlorine is a diatomic molecule, so they will pair up Cl plus Cl to give you Cl2 gas, and you will have a bubble of gases. You will see gas bubble going out at this point from the electrolyte. That gas is what? Cl2. Now let's see what happens at the, remember that's chlorine leaving the solution. Let's see what happens at the cathode. At the cathode, you have the cathode is negative electrode. So you have this and this going there to contest. Now, they are very far apart. They are not close by. But because of the nature of electrode we are using mercury as what? This is mercury. As what? As cathode. So because of that relationship that sodium has with mercury, normally it is hydrogen that's supposed to be discharged, because they are not close by, they are far apart, and hydrogen is below. So, but because of the nature of electrode we are using, sodium will be discharged instead of what? Hydrogen. So you have Na plus collecting electron, one each, to become what? Na, which is solid, and it will stick itself to the cathode, which is mercury. So sodium will stick itself to mercury electrode and make it bigger in size. Now let's see what happens. This is what is leaving now, sodium. The solution is now gradually becomes, it was sodium chloride concentrated solution. So sodium and chlorine are leaving the solution. Now leaving the solution to be what? More of what? Resulting in becoming dilute solution. H2O is still constant. So the solution will gradually be diluted. So that's what happens. We have treated electrolysis based on the position of ions in electrochemical series. We have treated based on the concentration of ion in the electrolyte. We have also treated about the nature of electrode. Watch those videos and subscribe. Follow up for more topics, interesting topics. Remain blessed till we meet again.